Jean-Yves, so I'm glad to be here for the presentation of the organizer. I was there for the 80 years celebration of the 80 years of Consistent Convenience, and I hope to be there for the 100 years commemoration. By the way, the birthday of Da Costa was in 2019. I mean, the 90 years of Da Costa. So I organized this time World Congress in Rio de Janeiro, and this school was supposed to happen shortly after the event, but it was postponed due to the pandemics. But at the end, we are here. This meeting, as you can see, there was a topic which was creativity. That I chose this topic because I think that Newton Da Costa is very creative. Also, I created this Newton Da Costa Prize of Logic, so I will say a few words about that, for his 85th birthday. And after that, I created other logic prizes in the world, in particular the Alfred Tarski Logic Prize in Poland. Nice. And based on different prizes we have in several countries in the world, I started to organize a World Logic Prize contest. So the first edition was the Janeiro in Vichy in 2018. The winner was Ivan Martinchak, you can see here on the left. And the second World Logic Prize contest was in Crete last year. The winner was Ciro Russo, who was the winner of the Newton Da Costa Prize. Because during those contests, it is a contest between different prizes of different countries in the world. And the next World Logic Prize contest will be at the next Unilog in Cusco 2025. I will say a few words about that later on. So let me say a few words about why I'm here in Brazil and how I met Newton Da Costa. So in this 1989, I was spending weekend with my girlfriend in the house of her father, who was a psychoanalyst, and I read an interview by Newton Da Costa in this journal, Lacanian journal, name is L'Âne. L'Âne in French is this animal that you can see here. And, yes, I will not explain why the journal is, why this is the name of the journal, but anyway. And then in this journal, there was an interview of Newton Da Costa here on paraconsitent logic. The relation between non-classical logic, especially paraconsistency, and the inconscious. And how, so I was quite interested in this, reading this interview. This was the first time I heard about paraconsitent logic, and I started to work on paraconsitent logic. But why an interview of Newton Da Costa in this journal, L'Âne? Well, Newton Da Costa is a friend of this guy here on the bottom left, George Forbes, who did an analysis with Lacan, and Newton Da Costa did an analysis with George Forbes during some years. And he presented, so George Forbes is from São Paulo, he presented Newton Da Costa to Jacques-Alain Miller, who is here on the top right, who is the successor of Jacques Lacan, and who started to be interested in paraconsitent logic. And later on, this woman who was the president of the Lacanian Society, she wanted to know more about logic, and she was a good friend of George Forbes, and suggests that I give some class of logic to her. So during some time in Paris, I was teaching logic to this woman, Thomas. Okay. Now in this, I did also, as you can see in this picture, I also did an analysis. In fact, psychoanalysis has been with two analyses. I think it's more efficient. Anyway, in this interview, in the journal Land, Da Costa, he quotes Pierre Curie, I remember this quote of Pierre Curie in French. I wrote this in French and also in English. Making your life a dream and your dreams a reality. And also there is this quote by Marie Curie, which is here on the small things for the books in the University of Competence. In life, nothing is to be free, everything is to be understood. So I think it's quite good inspiration for people who want to, because Curie, he wrote that when he was quite young. It's good inspiration for people who for young people who are doing research. Also, I will give another quote in this direction, which is related also with something like Da Costa likes to say. It's a quote by Nietzsche in an essay which is called Chopin Educator, which was written in 1874, where Nietzsche writes the following: we have to answer for our existence to ourselves, and will therefore be our own true pilots, and not admit that our being reserves a blind force duty. One must take a rather imprudent and reckless way with the riddle, especially as the key is apt to be lost, however things turn out. Why cling to your bit of earth or bit of business, or listen to what your neighbor says? So quite interesting. And I was much influenced by Schopenhauer. I wrote a paper about Schopenhauer, which is called Meta-Logic, Schopenhauer Universal Logic, which is published in this book, Language, Logic, and Mathematics in Schopenhauer, which is a result of a congress which was organized with the same title in Germany some years ago. So the work of Schopenhauer logic is not very well known, but it's quite important. In particular, he promoted, a few people know that, he promoted the word meta-logic. So in this paper, which is quite long, 50 pages, I explain what is the meaning of meta-logic for Schopenhauer. Now I will say a few words, before starting my talk, I will say a few words about difference. What I want to say is that I think it's very important to take part in some events. So I'm very glad that you are here, and I'm very glad that this school was organized. I think it's very important. And tomorrow we will have a session of the webinar. So during the pandemic, I started to organize some webinars because it was difficult to travel. And this is the third year of this Lógica Universalis webinar. We have 2 sessions per month, which are on Wednesday at noon in Brazilian time, but it's international webinar. And tomorrow we'll have a session of this webinar in this room, at noon, between noon and 1 o'clock. So the lunch will be open only at 1 o'clock. And you are welcome to attend the talk. Will be presented by this guy from India, who was supposed to come here, but at the end he didn't come. And his advisor is here, Shankar, and also the chair of the session, Rajan, who is a member of the board of the Joint Universalis, will be the chair of the session. He will be there. And L.Magnani will present the event to the people who are listening to us around the world. It's a way to promote this for people who are not here. Also, this year, last year, I started to travel again. to the polemics. And this year, I am organizing a different event, so I will say a few words about that. Since 2019, I'm organizing this day, so we really have this edition this year, January. Next event I will organize this year is an annual workshop in Paris. It is at the Sorbonne in Paris. In the picture, we already had 9 editions, published a book, and this year we have to start the workshop due to the pandemic. But this year we start again. It will be at the end of April. As you can see here, you have some photographs of some people who already started part to this workshop. And if you're in Paris, you're welcome to join us. It's a general workshop about logic. Then in September, I'm organizing this 4th World Congress on Logic and Religions, another project I'm working on, which it will be in Romania, in Siena, Romania. Then in 2024, since we are talking about paraconsitent logic here, and I will give a talk about paraconsitent logic, I think it's a good opportunity to promote the next World Congress on Paraconsistency. The last one was in Poland in the last September, and the next one will be in Oaxaca in Mexico in 2024. And the local organizer will be with PhD postdoc with me and sorry, Mr. Janeiro. Also, this at the same time, we will combine this event with the element on the square proposition, which is a topic which is related with paraconsistency. We will organize this event in several places in the world. I give you 2 examples here. It was in the Vatican in 2014, also, and in Easter Island in 2016. So this time it will be the 8th edition of this event. So you also welcome to join us for these 2 events in 2024 in Central America, in Mexico and Costa Rica. Then in 2025, we'll organize the 8th edition of the World Congress on School and Universal Logic with Philippe. He's here, so if you want to talk more, if you want to talk with him about the Cusco and so on, you can ask him some question. And it will be so in Cusco, which is a town in Peru, historical town in Peru, which is close to the Machu Picchu. Is also so he's the president of this Society of Logic and Epistemology, Peruvian Society of Logic and Epistemology, and recently he edited this. So we also was talking about this journal, South American Journal of Logic, which I am editing with Marcelo Colibio, and we had a special issue on Y.Beziau in 2020, where there are a lot of things were published, and especially the correspondence between Da Costa and Quesada about the expression paraconsitent logic. So you can have a look at this. It is open access at this address. In 2025, I will also organize a congress in Crete. I already organized 2 congresses in Crete. This is the first time. A congress on Plato's Cave, because Plato's Cave is on Crete. I did a master thesis on Plato's Cave. It will be a kind of interdisciplinary congress. I did this master thesis in 88. And I'm talking about that because it's related with a project which is connected with my presentation today, is the use of images in philosophy and in logic in general, in philosophy, logic, mathematics, and so on. So, in 2018, I organized a big congress, international congress on imagination in Rio de Janeiro. I also work on the different semiotics project, this workshop on the reasonableness of the sign in Geneva. And the question is how we can use images our imagination, of course, but not only our imagination in a very fuzzy sense, but concrete images to develop our understanding, philosophical understanding, reasoning, and so on. Images were, in some sense, rejected in the Western world due to some ideas promoted in Greece, in particular the cave. But the cave is a very interesting case because it's a rejection on images based on a picture. But generally, especially among philosophers, people have negative ideas. Have a negative idea of images because they think that images are not used in a good sense. And this is the case, especially in advertising. But nevertheless, we can use images in an interesting way. This is what I'm doing since several years. I intend to launch a new journal in the next future, World Journal of Pictorial Philosophy, where we will systematically use some images. So if you want to submit a paper, you are welcome. And since more than 10 years, I am writing papers, philosophical papers or logic papers, where the use of images is very important. You can have a look at these pages, you will see different cases. And today I will speak, for this talk, I will speak about images. So for example, this paper, which is directly connected with my talk today, which is titled of the paper is Cats That Are Not Cats. I use a lot of images. It was published in this book, tribute to John Woods. Also, in this other paper about, so this paper is directly related with the philosophy of Paraconsistent Logic, and also this one, which is called Round Square Are No Contradiction, where I explain why round square is not a contradiction, using some images. So I was organizing this 5th edition of the World Congress of Paraconsistency in India, and I use these images here as a poster of the Congress. And during the Congress, I decided to organize a contest about image related with contradiction. The idea was very simple. To take part to this contest, people had to send us an image, a picture of contradiction, and the contest was open not only to the participants of the Congress, but also to any people who was not able to take part to the contest. And it was a very interesting experience because we didn't receive a lot of picture images, maybe 10 or at least 15, and very few interesting images. So for me, it was the proof that people don't have any idea, if I may say, don't know how to represent contradiction. So it's typical of philosophy, because people say a lot of blah, 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 and then you ask them, but what is the contradiction for you? And they present quite a stupid picture, you know. Well, we had to decide to choose one of them as a winner. Well, I was organizing the contest, but I was not member of the jury, so this is not my choice. I will show the picture. It's not very interesting, but let me see. This is the winner of the contest. Well, not so bad, but and you decide if it's really a contradiction. Okay. Well, I'm working on using picture, and so modeling in civilization. So this is one of my postdocs. She was supposed to come here, but she's not. She's still. She's not here. She's in Bangkok. But I will say she is half Brazilian and half Chinese, and we were investigating some Chinese ideogram about contradiction. Okay, so the ideogram in Chinese in everyday life, there is one. This is these two. The two symbols go together, and as you know, the ideogram of Chinese are some kind of pictogram, and the origin of this sinogram is this picture here, which is a spear and shield. So this is how Chinese think about contradiction. Yeah. What does it mean? And we can, I will not here extend on this topic, but it is related to kind of a fight, as you can see here. And Mao Zedong, who is one of the most famous Chinese, he wrote his main philosophical book, if we can call this philosophy, is a book which was written in 1937, which is called On Contradiction. And the title of the book, here it's a translation in English, but the title of the book is this sinogram I was showing. And here there is a quote which is extracted from the book. If there were no contradiction and no struggle, there will be no process, no life. And there will be nothing at all. So you see, this vision of contradiction is related with this here, like a conflict, struggle, and things like that. This is not the only way that people can think, even in China, can think about contradiction. For example, if we have this very famous yin-yang philosophy in China, they are not using to represent yin-yang this Chinese ideogram, but they are using this very famous Tao symbol. And the yin-yang philosophy is very different from this philosophy related to this spear and shield. Because in the yin-yang, you have two things which are, in some sense, you can say opposite. It would be better to say opposite because it's more neutral, and which are interacting, but not in the sense of a struggle, because the idea of yin-yang is more like a question of harmony of the world. It's not a war, if I say. Okay. Now, let me say a few words about symbolism. I have been working quite a lot about that. I'm interested in semiotics, and I think it's very important to understand how symbolism works, to know logic and mathematics in general. There's a very famous picture from Egypt. In modern times, people have chosen this expression symbolic logic, which was originally promoted by John Venn, and it is related with some with the Venn diagrams. But this expression started to be used, in particular in the name of the Association for Symbolic Logic, or Journal of Symbolic Logic, in quite different ways. It's not the main topic of my talk, so I will not give a lot of detail about that. But it started to be used in a quite different way. On the other hand, before John Venn and before the Association for Symbolic Logic, there was a work of George Boole. And George Boole was influenced by something that was called, at the beginning of the 19th century, in England, symbolic algebra. And it's very important for the development of modern mathematics. So you see, in mathematics, people are using all these kind of signs, and which can be seen really as some symbols. One of the most famous symbols of modern mathematics was promoted by Jean-Yves, as you can see here. This is a symbol for the empty set. Also, a very famous symbol in mathematics for the development of modern mathematics, I mean modern in the sense of Descartes. Descartes also was a promoter of very important symbol in mathematics, especially the square root symbol. And this one is the most famous symbol of mathematics, and also, as written here, is one of the most universal symbols of humanity. This was promoted by a Scottish mathematician, and he explained why he chose this symbol, and so on. And this has a very big influence in the development of mathematics. This is explained in particular in this book by Michel Sarfati, which is called The Symbolic Revolution, where he explains how mathematics start to radically change at this time of Robert Ricord, Descartes, and so on, yet when they start to introduce a new way to write mathematics. I suggest you to read this book. And both start to do that, inspired by the British School of Mathematics in logic. Now, in his famous book, The Law of Thought, there is this proposition here. The principle of non-contradiction is a consequence of the fundamental law of thought, whose expression is x squared is equal to x. Okay, and there is a proof of this result. Now, if I ask one of you or one student of logic to prove this result, I think nobody will know how to do that. The proof of is 3 lines. Okay, and if I ask, if we ask a philosopher why, if he's able to explain why this is the y x to the square is equal to x is a fundamental law of thought, he will not say anything. No? Very few people are able to explain why who had the idea that this was the fundamental law of thought, more fundamental than the law of non-contradiction. It's very interesting. I wrote a paper about that. I will not go into the detail here. I will write a paper about this proof, how we can interpret it and its meaning and so on. And my first talk about this proof, was in St. Petersburg in Russia, so I make a joke, an analogy with the famous story here. At some point, so Euler is one of the most important mathematicians in the history of mathematics, and he was invited by the Queen Empress of Russia, and he spent most of his time in St. Petersburg. And he's originally from Sudan, but he spent most of his life there. And at some point, Guido was invited, a famous encyclopedist, philosopher, was invited to St. Petersburg to discuss, in particular, about various topics, in particular about religion. And this is a true story. Different report about that. And there was this discussion, the two were discussing, and Euler presented this equation to Diderot, and he said, hence, God exists. and not to France, but what does that mean? I mean, Diderot was not able to reply anything because his knowledge of mathematics was very poor. So he didn't know how to reply. And he didn't say anything, and then it's true that he went back to France. So I make a joke, which is the following. We can imagine discussion between George Boole and Marx, because at the middle of the 19th century, because it's true that Karl Marx, at some point, he went to England, spent several years in England, and we can imagine a discussion about contradiction between Boole and Marx. We know that for Marx, contradiction was very important because it was influenced by the dialectic of Hegel, where it is the central point. And we can imagine this discussion where Boole is presenting his equation according to which we can deduce the principle of contradiction, and Marx would not be able to reply anything, because how he will not be able to understand Moore's proof. It's kind of funny story. Okay, now let me start to the detail of my talk, which is the relation, first part will be the relation between paraconsistency, negation, and contradiction. So, you see contradiction, what is contradiction? So, generally, Paraconsistent logic is presented in this way. We say there is this formula, we can call this a formula. Now, the whole question is why I was talking about symbolism. Because what does this mean? Many people think nowadays, because in logic we are using a lot of symbolism, people think this is very obvious, very simple. This is not obvious at all, the meaning of this symbolism. It can be interpreted in different ways. And the famous mathematician and logician, Paul, he wrote a very interesting essay. I advise you to read this essay if you like to write mathematical logic. How to write mathematics, which was published. It's easy to find it online. And he said, in this essay, the best notation is no notation. It's good to be able to talk with someone without using any notation. Well, I don't necessarily agree with Paul, but I think it's quite interesting what he's saying in his about that. Well, no notation, and you talk. Yeah, but how to talk about what is the paraconsistent negation and so on. So I think symbolism in mathematics can be very useful, but we have to use this in a good way. Now, I don't think this is a notation. It's better to call this a symbolization. And we have here, at the middle of this notation, of this writing, this formula, and so on, we have the famous Frege symbol, which was promoted by Frege, but which is not at all used in the way that Frege originally Frege was using. So it's quite funny because there is nearly no relation between the origin of this symbolization and the way that it is used nowadays. I am working on that. I plan to write a small book, and I already give showing here what is the difference of writing this and this. And this is an important question because also there is a question, these P and Q, are they constant or are they variables? And the distinction between constant and variable was fundamental for the development of mathematics at the time of Descartes and so on. And in logic, there is still a lot, in modern logic it's very important, but there is still a lot of confusion about that. So if you ask, why don't you write that if these are variables? And do we have constant? Because, for example, in logic, in propositional logic, people say, we have some proportional variables. But are they really variables or are they constant? You see, there are a lot of problems, that are a lot of questions which are not clear. Now, about this Frege stroke, I gave a mini course during the Unilog in Vichy, and I plan to write a book about the history of modern logic, showing how the meaning of this symbol changed from Frege to now. It changed several times, and we have variation of this symbol, like the symbol which is nowadays used in model theory. I already wrote a paper about that, which is here in this hexagon. Now, let's go on this about this, let's call it formula. Can we say that this sign here, this symbol, is still a negation? And you see, I didn't put some quotation mark because the question is, are we talking about the sign or are we talking about the meaning of the sign? But the distinction between the sign and the meaning of the sign, everybody can understand. I mean, if we explain. But most of the time, when people are writing logical mathematics, they make a confusion between the two. So when I'm asking the question, is this means still a negation, I am not talking about the sign. I'm talking about the meaning of this sign. Sure. Does it make sense to use the same name and the same notation? Now let's imagine that we write this inequality. 0 times n is different from 0. Are we still talking about 0? Does it make sense to use the same name and the same notation? Well, but in mathematics, nowadays, it's very common to use the same sign to denote different things. For example, let me give you another example. 1 plus 1 is equal to 1. Is it still 1? Is there only 1, 1? Well, many years ago, people would have think it was completely absurd to write 1 plus 1 is 1. And also, nowadays, most of the people will say, well, this is false. 1 plus 1 is 2, not 1. But I mean, someone who studied a bit of mathematics at the university, you know that in Boolean algebra, we write 1 plus 1 is 1, because in Boolean algebra, 1 plus 1 is 1. And we use the same sign for that. So the question is there only 1, 1? No. I mean, nowadays we know that there are many different ones. But why are we using the same symbol? Because all of them have something in common. That's why. But they also have difference. In particular, they don't obey the same properties. They don't have the same properties. I wrote also a paper about that, which is called many one. You can read, which is accessible online. And up to certain points, we can use the same sign to denote different mathematical objects. In mathematics, people do that every day. But up to a certain point. So 1 plus 1 is 1. Okay, people are doing that. Now 1 times n is different from n? No. We don't write that. Because the fact that 1 is a neutral element for multiplication is considered as a fundamental property of 1. So there are some properties that cannot be rejected. Then people say it's not anymore 1. So 1 is a neutral element for multiplication, but the notion of neutral elements applies also to 0 for another operation. 0 plus n. So that's why I think it is good, and this was the case of Boole, to know how we proceed in mathematics when we are using symbolism in logic. Because it's a different way of thinking. Now, if someone and there are quite a lot of people in philosophy, they start to use kind of symbolism in logic and they know mathematics, they use symbolism in a limited way, a strange way, without really understand what they are doing. So let's go back to the question of Paraconsitent negation. Is it still a negation? Yes. If we have the rejection of what is called the explosion. And this is one of the most important points of Paraconsitent logic. And we can explain why. We can explain why because we can still have a lot of properties of negation which are preserved even if we reject exclusion. At the same time, even if we agree that it is still a negation, we have very good reason not to call the pair P and not P a contradiction. In particular, when this negation is a paraconsistent negation. So this P and not P, in general, is not a contradiction. It is a contradiction in the case of classical logic. Even in the case of inductionistic logic, it's not a contradiction. So, in paraconsitent logic, there are a lot of people who call this a contradiction. But there is no good reason to use this terminology. And if you don't use the right terminology, you are generating confusion, as we know in everyday life. Well, in the first World Congress on Paraconsistency, which was organized in Ghent, here, and he was one of the organizers and publisher of this book, which was generated after the Congress. I wrote a paper which is called, this was the title of my talk at this Congress, and the title of the paper which is in the book, which is called What is Paraconsistent Logic? Where I discuss this question. What I'm saying is that the negative condition is not enough, because you have a lot of logical operators which do not obey the exclusion, and nobody has the idea to call them negation. So, if we want to talk about a paraconsistent negation, we have to have some positive condition. But it's difficult because it's very difficult to find some universal positive condition for negation. And in particular, it is related with what I was saying the other day during the talk of Professor Ariely about contra-classical logic. Because there are some, we may think about, not only about positive property of classical negation, but also about property of negation which are not classical. For example, since we were talking about psychoanalysis, there is a very famous text by Freud, which is called the denegation, where in this text, Freud shows that most of the people, when they use the negation to affirm, if they say not P, it's because they want to say P. So from not P, we can deduce P. And there's a lot of discussion about that in psychoanalysis. So now, if someone wants to have a logic in which we have such kind of negation, it will be what these properties, one six recently started to work on that. So in my paper of 97 on the Congress in Ghent, I call this half paraconsistency, where you have P and not P is a tautology, which is against classical logic. Now, when we were in the Congress of Toronto last year, Francis started to talk about this also, develop a logic in which we have such kind of things. So this kind of, so Francis was already interested in connective logic, which is also classical logic. So all these kind of things were called by Lloyd Humberstone contra-classical logics in the paper published in 2000. We discuss about logic which are against classical logic. So they are not subsystem of classical logic, but they are different. Okay. Now, let me go to the question to some specific example of paraconsistent logic I've been working on, which is the logic S5. So S5 is a paraconsistent logic. I will explain what does it mean. So just after this Congress in Ghent, I went to the Four Colleagues in Fortaleza, in Brazil. And I had a discussion with one friend of mine here after Moscow. But this picture was a picture later on with Newton da Costa at the Congress, at the second Congress of Paraconsistency in Juquí, Brazil. I had a discussion with him about, well, what is the meaning of a paraconsistent negation? Because we can construct a lot of different kind of systems and so on, but how we can interpret a paraconsistent negation in the intuitive sense, in the philosophical sense. And it is not clear. there is no simple way to do that. So, and after, with this picture, he was telling me about some philosophical tradition according to which anything can be at the same time, in some sense, considered as true, at the same time considered as false. Okay, but it's very general. But we discussed about this and so on, and then I had an idea, which gave rise to this Paraconsistent Logic Z. I call it Z, and I will explain what it is. So I write this, I present it the next year at the Jaskowski Memorial in Toronto, and the idea of the negation of this Paraconsistent Logic is very simple, it's explained here. So the negation of P is false if and only if true, P is true for all points of view. And this is directly inspired by the idea of the discursive logic of Jaskowski, but Jaskowski didn't define its Paraconsistent logic, Paraconsistent negation like that, possibly in another way. But I think this was quite intuitive. So P is true from one point of view. It can be, what does it mean a point of view? It can be the opinion of the people, but also it can be the different ways something appears. Well, it's interesting, first of all, to note that the semantic of propositional logic is not something obvious at all, you know. People nowadays, they think it's natural and everybody is teaching the semantic of propositional logic as if it was something completely obvious. But it's something, in some sense, which was, this semantic was promoted basically by Wittgenstein, it's something, in fact, which is completely absurd. I will explain to you. Because according to this semantic of Wittgenstein, everything, and this is the semantic of the propositional logic, everything can be true or false. You know, you have theoretically, now you are using p-valuation or distribution of true values. The original expression used by Wittgenstein was, in the tractatus, is proof possibility. Well, so if you have an atomic proposition, and as we know, Wittgenstein was the guy who promoted the idea of atomic proposition, if you have an atomic proposition, it can be true and it can be false. But let's take an example, a very simple example. So before Wittgenstein, nobody would have said that 2 plus 2 can be false. There was no good reason to say that. But according to the semantic of Wittgenstein, this can be false. Okay. And also this can be false. Because it's an atomic proposition. And this can be true. So, even nowadays, if you say that to a mathematician, he will not understand. So it means that he does not understand the semantic of propositional logic, which is, in fact, not something obvious. How it works. And as we know, it was rejected by Wittgenstein himself. I'm not saying that the semantic of classical propositional logic is not a good idea. I like that. But people have some difficulty to understand why it is like that. Sorry. So, there is let me see if I am on the slide. What's the point of view in my idea of this Paraconsistent? It can be an opinion, but seen in the sense of Frege, in the distinction between Sinn and Bedeutung. According to Frege, Sinn is a way to look at something. The way something appears. Frege gave the idea of the different ways that we can look at a star. The morning star, the evening star, and different things, you know, like that. This is the point of view, and it is related with this very famous picture used by a physicist to explain the paradox of wave and particle. And Niels Bohr says the following: complete edition of of one and the same object may require different point of view, which define a unique description. That's how he justifies what he calls complementarity. And you can see this picture, which is nowadays circulating on the web. So you have this, I tried to find who was the originator of this image, but up to now I didn't find. But anyway, I think it's very interesting. So you have a cylinder, which is in the third dimension, and there is a projection in 2 dimensions. And you have a square and a circle, which, geometrically speaking, are opposite. And David Bohm, also a very famous physicist who makes some work sometimes in the University of São Paulo, in his book, there is a book which is called Goodness and the Implicated Order, where he gives some similar example between the two, something in 2-dimensional space and 3rd dimension. For example, it is how he tried to explain inseparability. Let's say you put 2 cameras on this aquarium and you have only 1 fish. Now, if you put these 2 screens, you have 2 fish, and you don't understand the relation between the 2. But the relation of the 2 is because it's the same fish. I did, by the way, I did a master thesis about David Bohm, philosophy of modern physics, with this French physicist Bernard Despagne. So I was interested in that before working in logic. I'm saying that because to develop this idea of logic, I was influenced by this idea of David Bohm and Niels Bohr, because I studied this before. So my idea of the definition of a Paraconsitent negation is very simple. The negation of a proposition is a false from a point of view, if this proposition is true for all viewpoints. Yeah. And this, you can write this in this way. I'm not using the symbol of classical negation because I want to make the difference between the two. Now, if we apply this definition to this picture, it works like that. We can say that this is a square and that this is not a square.
Yeah.
Because there is an object.
You have 5 minutes.
Yes. Yeah, 5 minutes. Not 5 minutes, okay. Understand. And then you can see that. Okay. This is a square, it's not a square. But the position is not in reality, because this object, this cylinder, it is neither a square nor a circle. That's the point. But there is no opposition in the contradiction. The opposition is the different ways that this reality may appear. So we speed up a bit, but this does not work. But this is only that the different opposition weighted here with the square proposition. And let me go now to some basic feature of the logic Z. We can, with this negation, which is a Paraconsitent negation, introduction, decision, implication. And we have a non-true functional duality semantic. This is a Paraconsistent logic. Yeah, okay. And we have some positive property which are similar to classical negation. Not all of them, but some of them, which you can find them. And we can define the classical negation in this logic. Okay. But more than that. So after my stay in Fortaleza, this particular in Fortaleza where I have this idea, I came back to Rio, where I was already living at this time, and I had a discussion with this famous Italian logician, which is living close to my house in Rio. And he told me, well, but your logic Z is S5. I was surprised, you know. And is S5. Why? Because this negation here, this Paraconsitent negation, is the classical negation of necessity, as you can see here. So, what is very interesting is that starting with a Paraconsitent negation of C, we can define classical negation, necessity, and possibility. So we can define S5. So it's a very interesting reconstruction of S5, and Z is S5. Okay. And more than that, first order classical logic also is paraconsistent because we can translate S5, we can translate first order logic in S5, and we can define a paraconsistent negation in classical logic using translation of Weisberg. And you also define modal logic, paraconsistent modal logic. So I will use 5 more minutes for the last part of my talk, which is also very important, which is related with what I was saying at the beginning, cats that are not cats. The paper is written, so you have all the detail on the paper. But I will say I would like to present this idea shortly. So, there is, I was inspired by this famous quote here, by Shakespeare, to be and not to be. And I will try to explain how it works, to be and not to be. Well, here, this is a cat. I think everybody will agree. And we can say this is a cat, it represents the species of the cat. But what about the negation of a cat? Classical negation of a cat. Well, classical negation of the cat, it's difficult to single out the classical non-cats, because all these kind of things are not cats. How you will represent this in only one image? And then we are back to the question of image. How you can represent a non-cat by a picture? Well, the way to represent a cat by a picture is to use symbolization. You put a cross. But that's how we proceed. Yeah, it's true. Yeah, and then you represent symbolism of negation. You know, cross or something like strike and something like that. Well, this is abstraction because negation is abstract. It is very important to know that. Now, here in this paper I have developed intuitive interpretation of a paraconsitent negation. And I am saying that this is not a classical non-cat, this is a paraconsitent cat. Because this is a cat and this is not a cat. I'm taking this example because in English, people we call this a cat, a big cat, but it's a cat. So, a tiger is a cat, not a cat. And we can say the same about this Felix, is famous, but not in the same sense. So the question of Felix is because Felix does not exist, it's a fiction. So so it's not a real cat. So there are different ways not to be a real cat. And all things which are not real cat will be paraconsistent non-cats, because they are cat and not cat. So this is a picture here, so you have C and not C, and both C and not C. And you can apply this to any kind of things. You know, this is an example of the Magritte about, with this picture here, a girl smoking a pipe which is not a pipe, because this is a picture, you know, and a pipe which is in a picture is not a pipe, because it's a picture, you know, so you cannot really smoke a picture. That's the idea. So, for this reason, you can have a paraconsitent negation of anything, because the picture of something is not a thing. So it's a very intuitive way to have a paraconsitent negation. Here, you have a chair which is not a chair, because this is a stone. So how can you say that it's a chair? Sometimes it's a chair, sometimes it's not a chair. You can see it on it. I'm finishing now. Now, this is related with the logic Z. Because in the logic Z, you can always have this case. Something can be and not be, except for tautology. If you have P or not P, then there is nothing in between. It's empty. You see. And this is so the interpretation about cats and not cats is related with the logic Z. It's a natural interpretation of S5. negation of partial negation of S5. Now, if we look at another system, which is very famous in Paraconsistent Logic, which is the logic, I'm just finishing. This is the logic of Assange and Prism. Well, what do you have? In this logic, P or not P, half. Not P or not P, half. So, in this case, you can have P or not P and not P or not P. And in fact, as I have proved in this little paper, Triviality and the Logic of Paradox, I show that in the logic of Assange and Prism, everything can be true and not true. So it's trivial. This is why I'm calling this trivial. Because it's not interesting, you know. Everything can be true and not true. If it were like that, what is the meaning of bilateral or Paraconsistent proposition? You need to have something which are not true and not true. Okay. Now, just to finish, also what we have in this logic of Assange and Prism, you don't have self-extensionality, and this is a serious problem. So I've been working on that, especially in particular with L.Magnani. And in 1998, already showed proof of general theorem showing that many logic, Paraconsistent logic, are not self-extensional. And now we had an exchange program with the University, so I was working with L.Magnani. And we were talking about that, and I told him, do you know of free value logic, which is Paraconsistent free value logic, which is self-extensional? He told me no, but let's see. And then we published this paper, we showing some sense. There is no free value Paraconsistent logic which are self-extensional. I mean, there are no implication. And then I asked him, well, so a free value logic does not work. So what about four value logic? I say, yeah, of course, we have self-extensional logic in four value logic. But I told him, well, but you know, the Nappen logic is self-extensional, we know that, but there is no implication. Then he told me, yeah, but it's possible to have an implication. And then, for this reason, he developed this paper, which was published in 2020, but in fact, he found only one extension of the lab with an implication, which is a logic which is self-extensional. So there are a lot of work to do with Paraconsistent logic, but there are only, up to now, as far as I know, there are only two Paraconsistent logic which are self-extensional. It's S5, because we know that the replacement time is valid in S5, and the logic of extended logic of Den and Bena. But I will finish there, but just to show that when we are working in symbolic logic, modern logic, mathematical logic, use the word you want to use, we have to be really careful because we have to be aware of the mathematical side of the system. For example, this logic, this free value logic of Assange and Prism from the mathematical side is not interesting, and also you don't have any philosophical interpretation of it. Now, if you want to have a system which is good for the mathematical view and which also has philosophical interpretation, is quite difficult. That's my conclusion.